Hi, I'm Emma Broman from Linköping University, and I'm happy to present our work on the ExoplanetExplorer, a tool for contextual visualization of exoplanet systems targeted towards exoplanet experts. I'm presenting on behalf of my co-authors, out of which 3 are astronomy researchers with expertise and knowledge of exoplanet systems, acting as experts and stakeholders in the design of the tool. Exoplanets are planets outside the solar system, orbiting other stars than our own Sun, and an ongoing field within astronomy research. The field promises great advances in the near future as a result of surveys made by modern space telescopes such as the James Webb Telescope and the Gaia survey. Experts in the field currently experience a lack of tools that allow them to efficiently visualize the result of the continuously growing datasets. Existing visualization tools, such as NASA's eyes on exoplanets, are aimed more toward curious members of the public rather than researchers, and struggle with showing information about the selected planet population in a spatial context, as well as allowing the experts to modify the data used for the visualizations. The work of analyzing exoplanet data is currently also a very time-consuming process for the researchers, often heavily dependent on manual scripting work and cross-matching datasets. There is also a lack of science communication tools that they can use to quickly present visuals of their own data and discoveries in a visually appealing way. In conclusion, they felt the need for a tool that puts the data at their fingertips and presents it in a way that is nice to look at. To address these problems, we utilized the existing 3D visualization tool OpenSpace and extended it with functionality tailored toward interactive exploration of exoplanets in their spatial context. At its core, the tool uses data from the NASA Exoplanet Archive, which is a multivariate dataset currently containing over 5,000 planets with over 100 different parameters. Although it should be noted that many of these values have high uncertainty and that there is a lot of missing values. The tool also gives the expert full control over the data that is loaded into the software through a Python script, and allows them to combine the base dataset with other datasets of interest as well as derive their own parameters. The data is then combined into 2 different interactive visualization views within the 3D scene of OpenSpace, an overview and a system view. The overview shows all exoplanets in the current selection as ring-shaped glyphs placed in their 3D spatial context, together with visual context cues that help identify the position of the planetary system. An example is the Milky Way rendering shown here. It is also possible to overlay other spatial datasets of interest, such as information about star clusters. Each ring corresponds to a planet, and planets in the same system are laid on top of each other, allowing us to view data about multiple planets even at a far spatial distance. This mode also allows interactive analysis through filtering, coloring, navigation, and picking, as well as an interactive table that acts as a familiar interface for the experts. Here, these features are demonstrated to make a reduced planet selection, which also reduces the visual clutter. The filter menu includes a few different types of filter, both custom per column, and some predefined filters for easy access. Navigation is performed by interacting with the mouse in the 3D view, and the windows can be moved around or put in a completely separate window compared to that of the rendering. The glyphs can also be colored by multiple parameters at once, in which case the rings are split up into angular segments, as shown in this image here for 2 colors. The system view shows a 3D representation of the system and its orbital parameters, and is accessed by selecting a planet in the overview and zooming into it. The view includes visualizations of the habitable zone, or the Goldilocks zone of the star, planetary orbits, including a disk that shows the uncertainty of the semi-major axis. The wider the disk, the more uncertain the orbit is. It also includes a representation of the host star, with a glare, color, and size depending on the star's size, color, temperature, and luminosity. And finally, some context cues, including a 90-degree inclination plane, an arrow that points in the direction of Earth, and a circle that shows the size of the system compared to Earth's orbit around the Sun. These can be toggled on or off as desired. In this mode, the expert can also add any custom visualizations that they might want to show for the system, using the built-in visualization functionality of OpenSpace. Finally, it's also possible to seamlessly navigate between the 2 views by zooming in or out in the 3D view. To evaluate our results, we performed a qualitative user study with 8 senior exoplanet researchers, including 2 of the co-authors. Feedback was collected during multiple activities in the form of remote and in-person interviews, where we demonstrated the tool and discussed potential use cases and feedback the expert might have. We also received feedback from 2 astronomy students after a presentation at the 2022 Sagan Exoplanet Summer Workshop. Some key takeaways from these meetings were that the overview mode allowed them to raise new questions related to their data when viewed in a spatial context. It was also considered useful for quick exploration of certain planets, and studying spatial distributions and finding outliers. However, the experts found the view a bit overwhelming, especially when multiple parameters were visualized using the spatial glyphs. This effect is somewhat reduced by filtering and looking at a smaller selection of planets, which was the main use case described by the experts. It also seemingly gets better over time once the experts get accustomed to the visualization, which aligns with previous studies of learning curves for advanced visualizations. The system view was well received as a science communication feature for communicating scientific results and what a system looks like. It also acts as a quick access point for both visual representation of the system and the relevant data. The visualizations were also considered to be visually appealing and suitable for presentations. However, the view was considered a bit too general, and its usefulness could be increased by, for example, showing a summary of information that the expert might want to see about the system at first glance, to decrease the time required to find out the important details. Another comment was that it's currently difficult to find out if an orbit has been created using default values or not. Finally, some other conclusions that came up during the meeting was that even though the expert did not explicitly mention it, the tool managed to facilitate scientific discussion. Just showing the tool to multiple experts in a room triggered a lot of scientific discussions between the experts themselves, as well as between us and the experts. Multiple times we ended up in situations where they wanted us to show a certain system they were currently working on and explain the interesting aspects of it. Furthermore, the researchers are also often teachers at university-level courses, and multiple experts expressed an interest in using the tool for teaching, both for creating content, for lecture presentations, as well as for student assignments. This was further emphasized through our meetings with the students, as when they got to try out the tool themselves, they were both engaged with the visuals and found the exploration in the tool to be an interesting learning experience. In conclusion, we presented the ExoplanetExplorer, an interactive contextual visualization tool that puts the data at the fingertips of the exoplanet experts and enables novel ways to analyze the vast dataset of the exoplanet archive. The presented prototype is a first step towards a tool that helps exoplanet researchers to enhance their research process, facilitate scientific discussions, and allow them to raise new questions related to their data when viewed in a spatial context. Thank you for listening.